Everybody, it's Dustin over at Geekmatics, and today I'm going to kind of go back to the basics and go over really what is step one in diagnosing certain issues with the iPhone, such as the rear or front camera not working, maybe your ear speaker not working, the mic not working, all of these different things that actually plug into the logic board. This is kind of the first step on how to diagnose them if they're not working. And what that is the use of diode mode on the multimeter, okay? Diode mode is a very useful tool. It pretty much tells us if the line is open, closed, or the reading on the line. And what you'll see in ZXW, and we'll get there, is that the ZXW will normally have the readings right on the kind of board view that they have there, and if they don't have them, normally LogiWiki has them. So with the variety of tools, normally good measurements are out there. Okay, so the diode mode essentially. And in order to test for diode mode, what we're going to do, the first step is we're going to put our multimeter in diode mode. And on my multimeter, it's the white icon there. It's a little diode. Okay, that's the mode we want to be in. And then when we're actually taking the measurements, okay, we're going to have red probe on ground, and black probe is where we're actually going to be testing each pin. Okay, why it's red probe on ground, I'm not sure. That's just the way it is. Okay, and you'll notice with my multimeter, when I have ground, it beeps. Okay, so that's what we'll be looking for as well. All right, so, and what we have today actually is an iPhone 7 Plus here that does not have front-facing camera. The front-facing camera does not work. So we're going to go to our first step in diagnosing, which is diode mode. We're going to be diode mode, the connector, and that's the connector where the front camera actually plugs into. All right, guys, now before I actually started to dive into the diagnostics part, I wanted to show you ZXW itself and what I was talking about with they have the measurements. Now this is the board view of the iPhone 7 Plus Intel version, and this is what's called A and B. A and B just means it shows you both sides of the board at the same time. You can also come down here and it will have the block view, and that will just kind of show you one at a time. On the older version it had two different screens, but I like this one better. So we'll zoom into where the front facing camera connects, and as you zoom in you will see the 31, 33, 35. That is the pin number, and then above that you'll see in red 0.628, 0.641, da 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 da. That is the actual diode measurement, and you can kind of turn that on over here somewhere if it's not automatically enabled. Somewhere in the front of my face, I'm sure. Oh yeah, view pin data. You can just kind of turn that off and on, and then you can also switch. Sometimes they have multiple options here, such as voltage. For voltage though, just to go over that real quickly, you don't always need it to actually be read to you because it will actually say it. So let's go to a power rail, find one here. There's one down here somewhere. All right, yeah, so right here's one. So if you look down here, you'll see PP1V2. That's telling me it's a power rail, and it has 1.2 volts on it. And if you actually look at net remarks, front camera DVD voltage 1V2 connector ports. Okay, so that's going to tell me that that's the 1.2 volt line for the front camera. All right, so now let's go ahead and actually get started on doing the diode mode measurements. All right, everybody should be in focus now. So what we're going to do is take our multimeter and kind of make sure everything matches up based off the way we have it. I'm going to try to make that as easy as you can see it. Get my multimeter ready with my thin probes. Okay, so we're going to start on the bottom right and go to the left. Now, one thing I did want to show you as well, you actually don't have to go through every pin if you don't want to. As you kind of gain experience, you'll see that you don't really have to go through every one. For instance, the piece that connects the front camera, right? Also, what else works off that? You have the proximity sensor, you have the front ear speaker, a couple of other things, camera, blah blah blah. So you'll see if you click on these lines over here, you'll actually see that the line name is front mic 3 to Kodak. Well, I don't have any issues with my mic, so I don't have to test that line. And over time, as you begin to work on this connector and take measurements of this connector, you'll just kind of start to jump right at the ones or the pins that you need to pay attention to. But for right now, I'm going to go from the bottom right to the bottom left, and then go back up to the top right and work my way to the left, and then kind of go that way. All right, so let's go ahead and get started. Going to again find ground with my red probe, and then continue on and measuring with my black probe. So let's see what we have. 513, and I'm not going to repeat them out loud because you guys can see them as well as what the measurement should be. Now if it's a little off, like you'll see 518, 520, and it's supposed to be 468, that's a little bit of difference I would expect. Now if it's like 100 or more, that's when I start to worry. All right. We're going to clean off that a little bit, make sure that the camera's not interfering with that. We might have just fixed our issue, we'll find out just by getting a little dust out of the way. All looking good so far. Beautiful, and on the end we should have ground. Check this in too, ground, good. We'll start up here. Oh, that's not normal. We have ground here when we should not. We should have 656 there. All right, so we have kind of discovered our issue here. We have discovered that we have a short on this line here. Okay, so what that could be is it could either be a short on one of these three caps, cap 1, cap 2, or cap 3 here. Now we do also have a filter, so unless this filter is blown, which means it's OL, then the cap could also be, or the short could also be on the PMIC side. Okay, so it looks like it leads directly to the PMIC. Oh no, we do have another cap right here. So our problem could either be the PMIC, this cap here, or one of these three caps. Now we know it's not our filter. While our filter could also be bad, and I guess in this case would be a good thing because that will make sure that it's not the PMIC and it's one of these three caps. But we know what I was saying was we know it's not our filter, okay, because a filter failing would not show a short to ground. Now it could have failed due to the short, but that's not our only issue, okay, if it's an issue at all. All right, so what we need to do is the first thing we're going to do is we're going to check our filter here, right? We're going to see if this is OL or if we have continuity across it. We're kind of hoping for OL, which would mean our filter is blown, but that would also mean it's one of these three. If it's not blown, that means, okay, it could be one of these three caps, but then it could also be the PMIC, and if we're lucky, this cap here. All right, so now let's go ahead and how do we detect a short? All right, guys, what we have here is a short, and we've already been over shorts and how to detect them in prior videos, so I'm going to briefly go over it, but we're going to kind of move a little bit faster. Essentially what a short is the electricity going to ground where it should not, and how we can identify those is normally where it's going to ground or where the short is will kind of produce some heat, okay? And how we're going to identify that is we're going to inject voltage into the line. But again, as I said, first we're going to check that fuse and see if it's still a fuse or see if it's blown open and kind of figure out what's going on and see which side of the fuse it's on if we're able to. So we'll go ahead and do that now. Alright guys, so if we look here, our three capacitors fuse, okay, are all in the underfill here, okay? So it looks like it's going to be all in this area that we need to check there. So in order to get there, we're going to come in with our real low heat, and we're going to kind of scrape away, it's what's called overfill, which is a lot easier to remove than underfill. Turn our heat way down, because this stuff comes off very easy. And we're just going to scrape it away. And I do have the board in a holder just because I don't like it moving around when I'm scraping this stuff away. And you can kind of see how easy this is coming off. And honestly, that's good just to check it. We don't need to completely clean it off, as we're not removing anything yet. We're just testing a couple of things. I'm gonna get all this crud out of my way. Alright. Take this out of the holder now. We don't need that anymore. Just hit this with a drop of ISO to, let's get everybody back in focus here. Alright, so like I said, we're going to check the fuse itself, okay, and make sure if that's, see if that's OL or if that has continuity across it. And we're kind of hoping for OL. While that would be another thing we would have to replace, that would mean we can rule out our PMIC. So it says the fuse is the first one underneath the connector. And my multimeter is off. Try this again. Uh-oh. Alright, so the fuse is still a fuse. So that means our problem could be PMIC. And if we check here, all of these are going to show shorts. Okay, so now the next thing to do would be to go ahead and inject voltage. Alright, and where I'm going to inject voltage is actually going to be on this side of let's do this side of the fuse and see if anything gets hot. And how we're going to do that is we're going to first freeze the board, okay, and kind of with our freeze spray, and then we're going to inject on this side of the fuse and see if any of these three capacitors get hot, and then we'll go from there. Alright guys, so one of the questions that I get is how do you know how much voltage to inject? And kind of as I just showed you, the line will say itself. Like, let's go here real quick to the line that is short, that we believe is short. It is, that's the wrong one, PP2V9NH, okay? So that will tell me on a good day, when the line is working, it should have 2.9 volts. So that's what I'm going to inject, 2.9 volts. What is normally on the line? And again, normally it will tell you kind of right there in that in the line name, okay? So that's how you determine how much voltage you're going to set. Alright guys, as you will see, I have my multimeter probes plugged into my DC power supply, and I'm going to go ahead and turn it on. And I'm definitely going to double check the voltage here, because as you can see, it's set to 20 volts. Looks like I was working on a MacBook last time I used this, so we're going to turn this down all the way to, what was it, 2.9 was it? 2.9 volts, there we go. And confirm that was what it was. It was, okay. And we're going to check our amp, our current, and we're going to turn this down. Ooh, come on. We're going to turn this down to about 3, okay? We don't want it to get too juicy. All right, so now, like I said, we're going to kind of freeze our board. We do have a wire going across because of this camera, so we're going to work with what we can. Now everything's all nice and frosty. Go ahead and inject our voltage. Oops. Let's try this again. Baby, come back. All right. Now we're frosty again. Everything got hot there pretty quickly. So with everything getting super hot there pretty quickly, it's kind of hard to determine if it's one of those small caps there. Alright, so what I'm going to do is I'm going to move the DC power supply, turn this camera off so I can get closer to it. Try this again. The camera in my way, I can fiddling with cables in front of me, it's harder to do this. So let's see, try try this one more time. It kind of gives me hope. Alright, it's on this side. Let's try this off. Let's try to go about this another way. Let's try some ISO. I don't see anything. Let's try this from the pin itself here. Alright, so actually, that's kind of telling. Let's do this one more time. So what I did here was I injected actually at the pin. So I'm going to add a bit more ISO. And you guys can see exactly what I'm looking at. Alright, so we're going to again inject at the pin. And look at what's getting hot there. Can you guys see it bubbling? It's the fuse that's getting hot. So if the fuse is getting hot, what does that tell us? Alright guys, since the fuse is the thing that's getting hot, what does this tell us? Is it that the fuse is bad? No. We tested the fuse. The fuse is good. That means that the short is not on the 3 capacitors that we talked about or was hoping that it was for. That means it's going to be on the other side of that fuse. The reason that fuse is getting hot is because all of the electricity all the voltage and current I'm putting there is rushing through that fuse as fast as it can to get to the short on the other side of the board. Okay, so that tells us that it's either that PMIC or that one cap, and I hope it's that one cap, because if it's not, this is a no fix. And I will still post this video, although it'd be upsetting that I didn't fix it. You would still get to see the process of how I got there and how I diagnosed the board. All right, so we'll go ahead and do a visual inspection on the other side of the board and see if that cap looks any kind of way. And then we'll inject some voltage there again, see what gets hot. So if we look at ZXW, all right, so if we look at ZXW, what we're going to do is we're going to flip to the other side of this fuse, or no, was it on the right side? Yes. And we're going to go to the other side, and we'll see the cap that we're praying that it is right underneath what looks like a coil. It is a coil underneath the Wi-Fi IC. So we'll kind of look and see what we have here. Get this in the same type of orientation. Okay. All right. Actually, that cap looks kind of nasty. If we look here, this is the coil we were looking at. This is the capacitor itself. It looks like it's gotten hot. All right, so and the PMIC looks all right. So let's see here. What we're going to do is we're going to inject voltage in this cap. Now since we're injecting voltage into that cap, it's not going to really tell us if that cap is bad, because what's going to happen is that cap is going to get hot even if it's a good capacitor, okay? But what I'm looking for is I'm looking to see if the PMIC gets hot. If the PMIC gets hot, that kind of tells me, okay, maybe it's the PMIC, even though that cap looks bad. So, but what I'm going to do is I'm going to go ahead and inject voltage into that capacitor, and again, we're looking to see if the PMIC gets hot, and we know already that the capacitor will get hot. So, again, we're going to use some ISO. Zoom out here and get some on the PMIC. Alrighty, and we'll switch you guys over. Inject some voltage into that cap. Actually, this cap literally, I didn't see the PMIC get hot, but this cap literally, well, it was moving around a second ago. Wow. All right, that cap is definitely, it's getting so hot, it's desoldering itself from the board. All right, let's go ahead and remove it. It seems very loose. I think I'm just going to be able to pick it off with some tweezers. Find some tweezers I like, but hopefully won't break. Like a loose tooth, just kind of peel it off here. Tore the pad off with it. Oops. That's okay. That pad will survive. Or it won't, but the phone will.
All right, let's see if the short has gone away. So now what we're going to do is we're going to hook up back to our multimeter here. And again, you guys will hear the beep if the short is still there. And let's check. Again, hopefully our desired reading is like 650 or something. And I got a quick beep and I have 786, which is still pretty far off. Let's see if this fuse is still intact. Yeah, I get that measurement on both sides of the fuse. So it's probably still intact, but let's just check our continuity across it here. Actually, I do not have, so it is blown actually. Oh no, there it goes. No, it is blown, okay. So we will have to, just for testing purposes, I'm going to jump it real quick. Because it's not actually fully blown, but it should have 0 ohms across it, full continuity, and it does not, as like a measurement of 121. All we need is a drop of solder there, or drop of flux. And it would make it easier if I tinned the wire. Then it would stick right away. Oh, there it goes. Tinned itself. Come on. Of course, I'm making a video, so it's going to be extremely difficult for me. All right, you just go back down here. As soon as you start making a video, that's when it takes forever to lay a jumper. And again, jumpers just for testing purposes. If this works out, I am going to replace that filter. Although, essentially a jumper and a filter are the same thing. They will both blow easily. There we go. Get that out of there. Get some ISO and clean up the flux that we left on the board. And again, we don't have to worry about cleaning it too much, because if this works, then I'm going to go back and actually replace that filter. So now that we have that done, let's go ahead and put this back in the housing. Where did I put the screen? Right here. Alright, now let's prompt to boot. Apple logo, good, that's always a good sign. Alright. And now we'll check the camera. The rear camera is not connected, so this will actually take a second or two to show up. More in a second or two, because Apple likes to be like, hey, I'm going to act like I don't work. There it goes. Beautiful. You will see that the front camera now works properly. Alright, so that is essentially how you use diode mode, and how you, essentially step one of how to start diagnose these things. And again, this works, broadly, no touch, no image, no front camera, essentially anything that connects to the board
this is a good method of diagnosing why those things may not work. And then again, the next step after this, let's say all the diode mode measurements were okay, everything looked good. The next step would be to check for voltages, see what voltages are present, what voltages are not present, and kind of go that route. And again, that will be a different video when we explore how to kind of do that. All right, so as always, I hope you learned something.